So the first example I'm going to do is very similar to your problem 7, except I'm going to use two different curves. The curves I am going to use are y equals x squared minus 1, which is my parabola that is shifted 1 down, and y equals 1 minus x squared, which is an upside down parabola shifted 1 up. And I'm going to use cross-sectional areas of squares. So basically what I'm saying here is that inside, in between these two curves, I want to make a square that comes out of the board that has this for its side length. Okay? So in order to solve this problem, I want the integral from a to b of my area function dx. Well, my area function, if it's a square, is my side length squared, and my side length is my purple function minus my blue function. So it's my purple function, 1 minus x squared minus my blue function squared, which would simplify 1 plus 1 is 2 minus 2x squared. That is my area function. In your book, if you look at problem number 7 on page 430, they give you a good three-dimensional representation of what this is looking like. You really don't need a three-dimensional representation. What you need is you need to know, hey, it's that region, it's going to be squares, and how do I calculate the length of my square based off of this? So now I'm going to do the antiderivative. Well, I need to know where these two intersect. They intersect when they are equal to each other. X squared minus 1 equals 1 minus x squared. Move this over here, and I get 2x squared. Move that over there, equals 2. Divide by 2, I get x squared equals 1. X equals plus or minus 1. So my bounds of integration are from -1 to 1 of my area function. So I differentiate, and that gives me 2x minus 2x cubed over 3, evaluated between -1 and 1. Evaluate at 1, which is 2 times 1 minus 2 times 1 cubed over 3, minus evaluating at -1, which is 2 times -1, minus 2 times -1 cubed over 3. 2 times 1 is 2. That's 1. That's -2/3. -2 times a negative is plus 2. That would be a -1. So that would be that part right there would be a -2/3, which turns into a +2/3, which turns into another -2/3. So I have 2 plus 2 is 4, which is 12/3, minus 4/3. And in this case, my area would be 8/3. Again, once you find the area function, all you're doing is integrating the area function between its left-hand endpoint and its right-hand endpoint, and that is how you're able to find this general volume, by slicing. I'm going to do one more for the general slicing. So the next example I'm doing is very similar to your problem 9. So 9M for modified. They want the volume of the surface formed between the x-axis, and in my case, the square root of the sine of x, from the region 0 to pi halves. And they want, in your problem 9 and mine, we're going to use isosceles right triangles. So first thing I want to do is I want to graph my region in the applicable area. The sine function between 0 and pi halves looks like this. Okay. And in each one of these, I want to make an isosceles right triangle where that's a side length then I have a side length coming out of the board, and then I have the hypotenuse. This one I'm actually going to try to draw for you. So this is pi halves. This is 1. There's my sine curve. What they are telling you is that you're going to have an isosceles right triangle here. And let's see here, you're going to have an isosceles right triangle. And all these isosceles right triangles are going to connect to each other. So you're going to end up with a curve that has a flat side here, flat side on that side, flat side on the bottom, flat side there, but whose side lengths are isosceles right triangles. And again, they have a very good picture of it on page 430 on your problem number 9. Key thing we want to know is we need to calculate the integral from my lower bound, 0, to my upper bound, pi halves, of my area function, dx. And we should remember that the area function of an isosceles right triangle is s squared over 2. And in my case, s is the sine of x, the square root of the sine of x. So squaring that would give me the sine of x over 2. So that's my area function. I'm going to pull the 1/2 out in front. And that's what I want to find the integral of. So what is the integral of the sine of x? Okay, or what function has its derivative as the sine of x? That would be negative cosine of x. So I'm going to have a negative 1/2 cosine of x evaluated between 0 and pi halves. So I need to evaluate it at its upper limit. So it would be negative cosine of pi halves over 2 minus negative cosine of 0 over 2. Okay, I'm going to put parentheses here, so you can see the negative 1/2 cosine of the lower, negative 1/2 cosine of the upper. Cosine of pi halves is 0. 0 over 2 is 0. Cosine of 0 is 1. 1 over 2 is 1/2 times a negative is negative 1/2 times a negative is positive 1/2. So the final volume of that region would be 1/2 square units.